between the two. But kicking right into it, really, why do people need window films? It's going to be one of these three things. They're either looking for comfort, they're looking for protection from the glare or protection from the heat. They're going to be looking for energy efficiency, and that's usually the building owners are going to want to reduce the load on their air conditioners, or it may be a safety and security and they want to protect people or protect goods. So those are the reasons why people are going to go there. That's one of the few common slides. So with that all sorted, we're into sun control films. So now we're talking sun control. So why do people need sun control? In a better explanation of what I covered in that other slide was it breaks itself into two. It breaks it down into these three on the top and these three on the bottom. Uniform temperature. So you want to try and control the temperature in the space. You want to reduce the heat coming in the summer. You possibly want to reduce the heat loss in the winter. So that's more about heat on the top, and the bottom half part is more about glare reduction or getting more daylight. These two tend to be almost opposite, or protection from the UV. So those are the sorts of reasons people are going to need sun control window films. So you'll have thermal comfort on one and productivity and well-being in the other. Now, most people, you'll need to talk to them. This goes back to to selling 101. Even though I'm a tech guy, 3M has run me through selling skills courses as well. So I fully understand what you guys as salespeople go through. And one of the first things I was taught was probe for the needs of the customer, work out what it is they want. And often they're not going to be able to tell you what they want, not because they're trying to hide it from you, but purely because they themselves don't know. So you need to ask a few questions, figure out what it is they need. And those questions it's not rocket science. It's not that hard to do. So you're going to have to weigh up with them between performance and appearance. So performance on this side, what do they need the film to do? Have they got a heat problem? So they want to reduce the heat coming through the windows. Is it a glare problem? Are they worried about the amount of light coming into the room? Is it fading? Are they concerned about the furniture or the carpets being faded by the sunlight? Are they simply looking for a UV rejection? Are they looking for privacy from the neighbors? That one's become quite a big one in recent years, as we've found that with a lot of infill housing, there are a lot of houses that are built very, very close together. And so we're looking for privacy from our neighbors. And this is one way of doing it. Maybe they're wanting to reduce heat loss. And definitely building owners are looking for energy savings. So that's for a performance perspective. The other side is appearance. Maybe they're looking for a particular color. Maybe they're looking for a low internal reflectivity so they can see out of the window at night. Maybe they're looking for external reflectivity for privacy, so they don't want people to be able to see in. Maybe they're looking for some natural daylight, but they still want to protect against some of these other things. So these are the sort of questions you want to ask. You want to figure out is what they're looking for. The ones in the middle that don't fall into either of those two categories, which we can do something about, is interference to electronics. That's a metal versus non-metal sort of conversation. We can put a window film on their windows that will block pretty much most of their cell phone reception if that's what they really wanted, and I'm sure it's not. We've also got a very high quality film, so you can use that to say, well, hey, we are using a high quality 3M film. 3M have been around for 120 years. They really know what they're doing. Also, the durability or the warranty or the service, that they may be hot factors that you need to highlight to your customers. And finally, budget. You need to figure out what your customer's budget is. And as I've said in other training courses, and I'll say it here again, everybody wants the Rolls Royce, but they only want to pay for the Toyota Corolla. What they need to understand is that if they have a particular need, that need may come at a price. Their need may be a lower cost film, that's fine, but often the needs that they'll have will result in a higher cost film. And they need, you need to make your customer aware that their requirements dictate a more expensive film. It's not that you're there to rip them off, it's just that their requirements dictate this different level of performance. So figure out what your customer needs before we even get into any of the selection process. Ask a few questions. Right, with that in mind, let's look at some of the features and what they'll do. First one is UV protection. Most glass will not reject UV, even if it's tinted. So tinted glass doesn't reject UV much at all. Our films will reject 99% or more, depending on the film, without even doing any sort of tint at all. We can put a clear security film on. Oh no, I've said it again, security. We can put a security film on and still get 99% UV block. So I've had cases where people's only concern was UV and fading, but they didn't want to tint the windows at all. They loved the sun coming in, they loved the light coming in, but they were more concerned about fading. So we found that a security film was actually the solution for them. But we were using it not for security, but for UV protection. It will protect people as well, and a good example is this. Oh, another point that I should make is this course is not automotive tinting. This course is specifically around buildings. I'm not talking automotive at all in this presentation. That's a completely different story. So, protecting people. These photographs here were taken from a dermatology magazine. This woman was a German truck driver, and in Germany, they drive on the other side of the road, so you can see the left side of her face was far more degraded than the right side of her face because she was getting a lot more UV coming through the glass of the truck window, and it was affecting her skin. So if we had put on a film that had protected from UV, we could have protected her face from the UV. So yes, even on people, we can help protect them. And also protecting furnishings and products in a retail environment. You can see here how the sun has faded the wood, but not under where the rug was. So the rugs got faded as well, and the woods got faded. So that's UV protection. Now, UV rays are the leading, but not the only cause of fading. I ended up with an argument with some guy at a trade show many years over this. The trouble was the guy had no idea what he was talking about, but thought he did. And that's, for those of us that do know everything, that's really difficult. So generally what we've got here is we've got UV being 40% of the problem. This is a rule of thumb. It's not, yes, there are studies behind this, but I, give or take a few percent. So about 40% of the causes of fading are UV. About 25% is visible light, about 25% is heat, and the remaining 10% are factors that are outside our control. So that miscellaneous 10% is the quality of the dyes and the fabrics and that sort of thing. So if you bring all of those things together, that's what causes fading. So the guys that didn't want to change the solar heat or the visible light, but they were concerned about fading, we could block out the UV with a security film. But more often than not, people will also want to reduce the amount of heat coming through the window or possibly cut out some of the glare. So pretty much most of our films will help to block against UV and against fading. Got an interesting tale with this one. Some years ago, we had an installer here in Auckland. It was a Korean gentleman who he mainly worked in the Asian market. So most of his customers were Korean or Asians. So there was another company that he was working with that brought in alpaca rugs, and they had a large storeroom which was also their showroom with all of the rugs in it, and they had wooden doweling with the rugs hanging over the wooden doweling. And he was called in because the customer was saying, my rugs are fading and it's in my showroom. I'm really concerned about the rugs fading. What can you do? So he went in there and he chose a window film that was quite a dark tint because it was going to do a very good job of blocking the solar heat, the visible light, and the UV. So it was going to block around 70% of the fading problem. 77%, I think, was the figure that we had in mind there. And the owner also said, oh, my office next door, my workers in my office also are struggling a bit. So they went in there and they had a look, and he specified a lighter tint because he wanted more light in there so that people could actually see. So they chose two different films, a lighter one and a darker one. And when he came to do the job, the owner said, oh, no, I want the lighter one in the showroom and I want the darker one in the office. And the installer said, yeah, but that's not going to work. quite the way you want it. No, that's what I want. So he went and did the job just the way the company owner said he wanted. And then a few weeks later, the owner phones up saying, "Oh, the rugs are still fading." And the installer said, "Well, you didn't use the film that I recommended. You chose this other film." And then it went from bad to worse. And next thing you know, he's being taken to the disputes tribunal over the whole thing. We got brought in as an expert witness, and I explained all of this and sort of tried to get them to explain that he had chosen the right films, but the owner had made the selection to change it around. Ultimately, he ended up paying about half the cost, but he shouldn't have had to pay anything. But just a word of warning that you want to be careful. Now, in hindsight, I think the rugs that the owner was claiming were probably already faded. So he was looking for someone to pay for the costs of his rugs, and he used this as a good excuse to do it. So just a word of warning, be very careful when you're talking fading. We cannot prevent fading. Never, ever tell the customer you can stop the fading. All you can tell them is you can reduce fading, and just be very careful if you make a selection and the customer changes their mind, so you don't get into poor old Mr. Min's problems. Next slide. Right, this is a lovely one. Who remembers this one? This was the Rabobank office at the end of Papanui Road by Beeley Ave in Christchurch. And there was a couple that decided to have a bit of fun one evening after everyone else had gone home. But what they didn't realize was that they were making love on the desk in the bank, directly opposite the Carlton Hotel, and the window film works in reverse at night, because what looks like a mirrored film during the day will reverse itself at night, so everybody could see in. So the bar patron Snap employees having a late night romp in the Christchurch office, and apparently the woman, the husband, the man, his wife found out via Facebook. What a way to find out your husband's having an affair. So a word of warning, window films that are tinted or mirrored will only work when the area that you're looking from is brighter than the area you're looking into. So during the day with the sunlight outside, you won't be able to see in, and that's what this couple thought. But at night, with the lights on, you will be able to see in. You can't disobey the laws of physics. The laws of physics say you will always be able to see into the more brightly lit area. What we often get asked is, for something like this scenario where you've got an interview room or a lineup room or an interrogation room in a prison or a police facility, we often get asked, what can we put on the windows so that people can't see into the viewing room? And we would say generally something like silver P18, and we'll talk more about what that is later. That's a silvered film with quite a dark tint. Now, the rule of thumb, and it's not written on this page, I probably should put it on there, 4:1. You want 4 times more light in the brightly lit area than in the area you're looking from. So you need that 4:1 ratio to make this work properly. Now, we've had one where people said there's a massive loading dock and they want the office to be able to see into the loading dock, but they don't want the people in the loading dock to be able to see into the office. There was no way they were going to get the ratio of 4:1. They could not light the loading dock brightly enough to get that ratio without making the people in the office work in the dark. So what we did found that worked was that if we had bright lights above out in the loading dock, just above the windows, shining down across the windows, we got the 4:1 ratio around the window without having to light the whole area. So that tends to work as well. So privacy depends on the light source, 4:1. Doesn't work at night with the lights on, as we saw here. So you can get privacy and it does work, but you've just got to follow those basic rules. So the next one is aesthetics. In this case, we're still looking for that mirrored tint, but we're looking for aesthetics to make on this side. Apparently, this is the UN building in New York. I haven't actually checked, but I'm told it is the UN building. They were really concerned that during the day, they had this really mottled look, and it depends. Some people had blinds open, blinds closed, and the trouble was you could see in, and it made the building look really mottled. So the building owners decided to refit the entire building with a mirrored film, purely to give them more privacy into the building, but a more uniform look. So that's before and after. You can see while it is mirrored, it looks far more uniform and it makes the building look a lot better. So that's using a film to improve the exterior appearance of the building. Now, the exact opposite of that coin is you can also change the film on the windows to give you benefits inside without changing the original appearance of the building. In this case, and it's an apartment in Sydney. You can see the Harbour Bridge and the Opera House, where the apartment owner or the body corporate for the building would not allow any of the owners to put window film on the windows that would change the external appearance of the building. The last thing they wanted is this sort of look where some people put window films on and others didn't, because all of these are privately owned, but the body corp has control over the building, so they couldn't force all of the owners to do it. So they basically said, well, if you do put window films on, they can't change the external appearance. And in this case, our Prestige range would do a good job of that. You wouldn't know from the outside that you had Prestige on the windows, but from the inside, they're cutting down the heat and the glare coming through the window. So this works for them and it does exactly what they wanted it to do. And you can actually see those two windows have been done, but those two windows haven't. So there's a slight tint change between those two and those two. So opposites. Changing the exterior appearance or not changing the exterior appearance, so you can affect the aesthetics of the outside of the building. Uniform temperature. So you can balance the temperature within a building. This is really more for the owners of large buildings. Heat control benefits for air-conditioned buildings. So what we often get is that you'll get situations where the floor of a building, complete floor of a building going completely from east to west. In the summer, the sun comes up and heats the eastern side of the building. So the poor old air conditioner says, oh, okay, the eastern side's getting hot, I need to cool it down. Yet the western side of the building is still cold because the sun hasn't got to it. So the air conditioner is fighting itself because it's trying to heat one side of the building while it's trying to cool the other. And the air conditioning, the load on the air conditioning trying to do that is massive. Or in the winter, the northern side's too hot and the southern side's too cold. If you put sun control film on that window, what you do is you will stop the sun beating in that window. So you'll stop heating one side of the building by the sun and cooling the other. So the air conditioner load comes off because the temperature inside the building is much more even and it will maintain a much more even building temperature. So you get greater occupant comfort all day and all year. Although saying that, you do need to be warned that it doesn't matter what you do, you will never make everyone happy in a building. Any building engineer will tell you the biggest source of consternation for people in a building, everyone wants at a different temperature. Some people are going to be too cold. Some people are going to be too hot. It really just depends. Everyone's going to be different. So all I could say there is do your best. The building owner, you can balance the temperatures and try and even out the temperatures, but you'll never make everybody happy. The next one is for the regards to the energy efficiency. We can lower the demand on the HVAC systems, heating, venting, and ventilation and air conditioning. We can lower the demand on that, so we lower the cost. We can reduce the peak load demand, which can be really important if they're paying a price depending on the time of the day. And a lot of these buildings will be time of day based. So they'll pay more for energy at different times of the day. So by taking the load off the air conditioner, they can take out the spike in load demand so they can reduce their costs that way. We can reduce the cooling costs, and we're also reducing the heating costs. It will save replacing the windows, and I've got a slide on that coming up, and you'll end up with more natural light coming in. So, energy efficiency, it goes towards green buildings. So there are a lot of, there's the software out there that can manage this and can show you how much energy you'd save. The trouble with the software that does all of this and works out the energy efficiency is massively complicated. And I've got a list of questions, probably a stack about metre and a half high of questions that you need to know. Questions like, where is the building? So we're going to need its GPS coordinates because that'll have an effect on where the sun will fall between winter and summer. We'll need to know what's called the azimuth coordinate of the building, and that's how that building is rotated off north. So every building will have an azimuth coordinate. If your building faces directly north, that coordinate is 0. If it faces 45 degrees off that, then obviously it changes the azimuth coordinate. Who would know what the azimuth coordinate of their building is? These are the things you need to know to work it out correctly. Then other things that would need to know in there would be things like how many windows there are, how big are the windows set back from the envelope of the building, so the windows recessed, that makes a difference. What sort of glass is in there? Is it double glazed, is it single glazed, how thick is the glass? Then we also need to know a lot more about the building. We need to know the energy costs. So what are you paying per kilowatt hour? Are you paying a daily charge? What is that daily charge? What sort of heating, venting, and air conditioning systems have you got in there? Are they all run by electricity? Are they run by gas? Are they run by diesel? We've got to get all of those details. Once you've got all of that sort of thing, and it is a massive list of questions, once you know all of that, we can then model the building, and we can come up and say, okay, we know from the calculations how much you'd pay a year in energy, in the costs to heat or cool this building. Then we can model by putting on different window films, and we can work out what the new energy costs will be, and obviously the payback. That all can be done, but in all of my years, I've never ever done it on a building in New Zealand, because by the time we roll out the list of questions, most building engineers take one look at the questions, their eyes roll back in their head in horror, and they think, oh, that's fine, we'll just we'll just guess it, we'll just go for it anyway. So while we can model it and we can get all these energy efficiencies, I've never had to do it here. We can get it done, but we've never had to do it. As part of the upgrade cycle to optimize the building, this one's a really difficult one for you guys as window film installers, because what happens here is we start off with the building owner totally without any thoughts to anybody else. They think, well, okay, we've got a problem. We want to optimize the building efficiency. So we'll do some benchmarks. We'll work out what our energy costs are. With a bit of education, they'll work this out. Then they'll say, okay, this is where we want to get to. So they'll set some targets. Then once they've set their targets, the first thing they'll do is a thing called retro commissioning. They'll go back to their standard heating and air conditioning and work out just to make sure that it is actually working correctly. So they'll get the air conditioning guys in just to check, just to make sure that all the filters are clean and all the motors are running efficiently, and everything's running the way it should. Then they'll look at the lighting and they'll say, okay, have we got energy efficient lighting? Can we swap to LED lighting or other forms of energy that are going to be more cost effective? And then they'll often go through that step so that they can reduce the lighting costs, so that will reduce their energy costs. Then, because they have no understanding of doing anything with window film, they'll often jump over this step, which is you guys, straight to changes to the air conditioning units and putting in bigger, more efficient, larger air conditioners. Then they'll go and measure it and say, yes, oh, yes, did it work, or no, it didn't. That can be a very, very expensive step. Your difficulty is that they don't know to come and talk to you guys. So the more you can get out there and talk to people in the industry and make people aware that changing their rather than changing the windows or changing the air conditioner, putting a window film on can reduce your costs. This is a very much cost-effective step. It's a heck of a lot cheaper than putting in new air conditioning. But your problem is that most of these guys, you won't even know they're considering this unless they've thought of this. They'll be jumping to this and you never would have got a look in. So it's a difficult question for you, but if you can end up talking to building engineers, this may be a step for them that they hadn't thought of. So it's difficult for you guys to do, but it is the correct step if you can manage it. Okay, so the conclusion for that is greater thermal comfort. So really what we're saying is that we can reduce peak temperatures, make them more even, so make people more comfortable in their houses or in their offices. We can reduce the use of HVAC, so we can reduce anything up to 70% from 7 hours to 2 hours during the day. That sounds like quite impressive. And also energy savings, CO2 reduction, all of the green sort of steps. So that's a brief overview of ways that we can help the customer. Now, changing gears again, selecting the right window film. When you select a window film, there's a bunch of things that you need to take into account. The first one is a thing called thermal stress. This is where the glass absorbs energy when it's exposed to the sun. Any glass will absorb some energy when it's exposed to the sun. So when you put a tint on a window, it will absorb more energy. So what will happen is we're not necessarily going to break the window, but by putting a tint on the window, you will increase the load on the glass. How much you increase the load on the glass and whether that's a risk is something that we'll talk about in a moment with the glass checklist. But usually thermal stress and breakage will occur when there's a temperature difference in the pane of glass, and you can see here some causes of thermal stress. Different types of glass will load up differently. So if you put a coating on there or a tint in there, it will increase the temperature load on the glass. This, strangely enough, you wouldn't have thought it, but that is probably the biggest cause of glass breakage, shading on the window. So you've got cold night, sun comes up in the morning, beats on the window, the sun loads the temperature on the glass, and this part of the glass is shaded by the tree, and this part of the glass is cold. So the cold glass and the hot glass, the difference between them is where the thermal stress occurs, and that's where you can break the glass. So look for shading on the glass. If you're going out to look at a job, see if there's anything shading the glass, whether it's an architectural overhang or a column or a pillar or trees outside. That can make a big difference to the stress that's added to the glass. Other things to look for are curtains or blinds inside, because they can reflect that sunlight back onto the glass, loading up the glass even further. Heat vents near the glass can cause localized heating on the glass, and sometimes the framing system can have an effect as well. So all of those things can cause stress in the glass. So what we can do is a thing called a glass checklist. Now, I'm not going to go into the details of it here. There is actually a 3M website that we can go to add all the details in, and it will ask all of those questions like, how big is the glass? What type of glass is it? How thick is the glass? Is there any shading? How high are you above sea level? Are you in a very cold environment where there's a lot of snow around? A whole bunch of questions, so it can correctly work out the stress on the glass. And from that, it will show you, it will highlight in red films that won't work, and it will highlight, leave in black the films that you can use. So you can make your selection of films based on the checklist. You don't need to do a glass checklist for every situation. I know some people do, but the glass checklist will give you a very, very good indicator of issues that may be out there. Essentially, the way I think of the glass checklist is a really, really good way of protecting yourself. While we can't guarantee it, even with a checklist, we do know that if you follow the checklist, then the chances of having glass breakage are going to be. With the glass checklist, essentially what I would look at is, have we got single pane glass larger than 9 square meters? Or have we got double pane glass larger than 3.7 square meters? If that's the case, then you want to do a checklist. 3.7 square meters, well, 9 square meters is a massive, massive window. Double glazing larger than about a ranch slider. If it's clear and it's thicker than 10 millimeters, if it's tinted and it's thicker than 6, all of these are indicators that you should be looking at a glass checklist. Before I carry on there, like when it comes to glass checklists, what you'll often find is that when it comes to glass breakage, often the way I describe it, it's not your fault, but it is your problem. Because your customer will say, oh, it didn't break until you came along and tinted it. Doesn't mean it's your fault, but it is your problem. You'll have to sort it out. You'll have to work out what happened and why and explain this to the customer. So many people will discuss it with them beforehand, saying, look, we will add stress on the glass by putting a tint on there. It's unlikely to break the glass, but it is something that we just need to be aware of. So the customer is aware before you ever do the job that this is possible. If you're at all concerned, doing the checklist will give you a measure of happiness, for want of a better word. It'll just give you a measure of security that it's going to work. Okay, carrying on down the list, architectural shading. That's what I was saying, extensions, columns, pillars. Shading is probably one of the biggest causes of glass breakage, so do check the shading on the window. Window framing systems of concrete, solid aluminium or solid steel. I've never seen glass framed straight into concrete, but I have heard it has been done overseas. Solid aluminium is not that common, but solid steel, if you think of what they call crittle windows, which is very much old school, and it is often in the old schools where you get a bunch of small panes of glass, and every pane of glass is actually held in with a solid steel edge. So it's not puttied in and it's not held in a rubber gasket, it's actually framed directly into the steel framing. So those sort of things I'd want to be careful with, because any expansion or contraction in the metal is going to add stress into that glass. Glass where the sealing or glazing compound is hardened, think putty, putty will harden. Buildings with more than 1% previous glass breakage or problems over the last 2 years. The trouble with that one is that you're never going to get the truth. And it's not that people are trying to lie to you, but if you say, oh, have you had much in the way of glass breakage over the last 2 years? Most building owners would have, I don't know, I don't remember. How the hell can I remember that? So you're never going to get the correct answer. Now, reflective glass, you can get glass that has already got reflective coatings in it. You may want to do the checklist for that purely because it's going to, it'll just give you a bit more information. If it's laminated, single or double pane and fairly large, then I would look at the glass checklist. If the window frame is damaged, I would definitely do a checklist. So if you've got one where the frame is actually dented or dinged or twisted, then definitely do a checklist. It's going, you've got a very, very good likelihood of that glass being broken. And that one, incidentally, is a very, very common scenario for Wellington, Blenheim, Kaikoura, right the way down to Christchurch. You guys are in an earthquake zone. You guys are quite active. Anytime you've had an earthquake, you can put a lot of stress onto that glass. So what we find is that even though you can't see damage on the windows, I would just go with caution in those areas. We've had a lot of ones in Christchurch where the windows look perfect, but because the earthquake has twisted the house slightly, the glass is now wedged into the frame and is pushing in the corners, and there's a lot of stress on the glass. So the installer goes to put tint film on, window breaks, customer unhappy, but it's not the installer's fault. It was the fault of the earthquake. But once again, not your fault, but it is your problem. And obviously architecturally odd-shaped windows, anything larger than 2 square meters, I'd want them to do a checklist. I had a wonderful one a number of years ago. One of the window film installers gave me a call and said, look, I want you to come and have a look at this house with me. I'm a bit concerned and I just want your opinion. So I went out and had a look, and it was a lovely old home, turn of the last century home in Remuera in Auckland. Beautiful house, multi-million-dollar house. And in the upstairs master bedroom was the most beautiful round window. So it was more like a sun or a starburst. So circular window, circular piece in the middle, and quadrants all the way around the outside. And they wanted a tint on there to prevent the glare and the heat coming in. This was fabulous. Of course, we didn't lie down on the bed, but the owner was saying, look, when I lie down on the bed, I've got this most beautiful view of Rangitoto out the window. So whoever architecturally designed that building, 100 and something years ago, did a really good job. Now, the reason they were concerned is that it was all wood and it was all puttied and it was all hardened. So the installer was right to be concerned and ask for some guidance. We worked out that we'd probably be okay because nothing was particularly large. Even the circular one in the middle was probably only 700 millimeters wide. pays to check odd-shaped windows. Now, in this case, you do need to perform a checklist if you've got Prestige 40 on double pane glass, if you've got blinds or curtains. A neutral 20, which is a very dark tint on double pane, you want to do a checklist because we've known that these can be an issue. If you've ever using an automotive tint on an externally facing building window, you want to do a checklist. Automotive tints are a completely different beast. We do not normally recommend using an automotive tint on standard flat building glass, but people do it. So if you are going to do it, the checklist will take that into account, so you can actually check the automotive tints on building windows as well. And I would definitely do it because they are quite a different beast. They're made in quite a different way, so they will react differently on windows. So it pays to check it if you are using an automotive tint on a flat glass window. Okay, this section here, window tinting is not recommended for wired, textured, or patterned glass. Patterned glass, obviously, window films are made of polyester and they will not conform to the pattern. You won't get them to sit down in the pattern. So there's no point trying to tint a patterned glass window. What I have seen is patterned glass tends to be very patterned on the inside and much smoother on the outside. I've seen one where a customer got the glazier in to turn the glass around so that the pattern was to the outside. Yes, it's going to pick up more dust and dirt, but the smooth side was on the inside so that she could put security film on there. That's just what she wanted. So we don't recommend doing it, but it worked for her. So textured and patterned glass. Now the other one, wired glass, sometimes we call that Georgian glass, commonly seen in schools or in doors and things where you've got that mesh frame, that wire mesh embedded in the glass. Do not attempt to tint wired glass, simply for the reason is that the tint will add a little bit of a load into the window, and that energy load will expand the wire in preference to the glass, and you can break the window. The wire expands and breaks the glass. So don't try and tint wired glass. Triple pane glass is not that common in New Zealand. It's very common in cold climates like Scandinavian or Nordic countries. Double pane glass in conjunction with a suspended film. Try and say that 3 times. I've never seen one here, but it is possible to get 2 panes of glass and a piece of film that gets stretched in between them. So it's like a third pane, but it's not touching either pane of glass. I've never seen it, but apparently it is a thing. And if that's the case, then don't try tinting that because you will get all sorts of strange effects on the suspended film. Partial applications of a film to a pane of glass. Don't tint half a pane of glass. If you're tinting the pane, you tint the whole thing. If you tint half a pane of glass, essentially it's like your shading problem. You're going to end up with a problem. It's very, very likely that you will break that pane because you've only tinted half of it. The only time I've seen that one work was there was an Indian takeaway in Willis Street in Wellington where they had people sitting in a table right next to the window, and they wanted to provide some people that are sitting at the table having their lunch. So they tinted halfway up the window just to provide some privacy. So when you were sitting down, you were protected by the tint film. Above that, you could still see in. So people walking past were high enough still to look in so that they could see what food was available, but the people sitting next to the window were protected. The only reason they got away with that was that being in Willis Street, there is an overhang from the building doorway or windows to the street. So that veranda protected those windows from sunlight. They never got direct sunlight on them. So it didn't matter that they'd only tinted half the pane because the sunlight never struck the window. But essentially, I would never, ever recommend tinting half a pane of glass. It will end up in tears. Application of more than one type of tint to a pane. What I mean by that is don't tint the tint. We know it's been done, we know it works, but we don't recommend it. We do not recommend tinting on top of tinting. The reason for that is that multiple layers of film are not going to hang on to each other as well as one layer of film to the glass. I do know people have done it and got away with it, but what I would recommend is if you go to a job and there's a tint on the window, oh, the tint's not dark enough, can you add another layer to make it darker? Say, no, we'll remove the tint that's there and we'll put on a darker tint. That way they'll get the full warranty and they'll get everything. If you tint the tint, we're not going to warrant it. Although I know it's been done successfully, I still can't warrant it. Okay, the next one, visibly brittle, chipped, cracked, or damaged glass. And I can hear you all thinking to yourselves, what on earth would I want to tint broken, chipped, or cracked, or damaged glass? Why would you do it? There has been one case where I know that was done, and it was a good, valid reason. The obvious reason is that why are you tinting damaged glass? Get the thing replaced and then tint it. But in this case, there was a valid reason for doing it. Up in Northland, many years ago, there was a school that had their main building had been condemned. It was moving, the foundations were moving on the building. It was many, many years old. And they had a row of upper windows, one of the ones that you open with the crank to open the windows up. I'm sure everyone remembers that from their school days. Those windows were cracked because the building had moved. They knew that this was probably the middle of the year, and they knew come Christmas time that building was going to be demolished and replaced with a new building, but they needed to protect the students in the building until the end of the year. So they put on, in this case, it was a security film, but they put a film on those windows just to protect the glass so that the glass didn't break and fall out. Yes, they were cracked, but they were concerned that the movement in the building would rain glass down on the students. So the only time I've ever come across that one being a valid thing to do was in that case. The last one, they're glass blocks. That sort of goes without saying. Everyone knows the old 1970s glass blocks are all about this big, all cemented together. Most glass blocks are textured, so if you're thinking glass blocks, think up to here, textured, don't do it. But the other reason for doing glass blocks is even if they are smooth, is everyone's only that big. Your application costs are going to be astronomical if you've got thousands of glass blocks to do. It's going to take you forever cutting around every single one of them. And that's the same reason why a lot of people don't like colonial glass, where you've got nice big windows, but every single pane is only 100 millimeters square, and you've got to put tint on every single one of those 100 mil square windows. Yes, it works, but it's just absolutely nightmare time consuming. So if you are doing colonial windows, go for it, no problem at all. Just make sure that you've costed it correctly, because it will take one heck of a long time. Okay, changing gears again. How do these films work? Okay, this is the technical bit, and if I lose anyone here, feel free to ask questions later. This is probably the most complex part of the whole thing. I've got a bit of an advantage on you guys. I've actually got a degree in chemical engineering, and we do cover energy balances and things, so I do understand this pretty well. But I should be able to explain it in words that, in ways that you should understand. So here's the sun. Here's our window and its frame. When the sun strikes the window, it's what we call the incident light. So it's the energy of the sunlight striking the window. Some of that energy is going to go right through the film. That's the transmitted energy. Some of it is going to be reflected off the front. That's obviously reflected energy. And some of it is going to be absorbed into the glass. That's what I was saying, is we can get energy absorbed into the glass. By tinting this, we will increase the absorption in the glass. How much goes through, how much gets reflected off, and how much gets absorbed? Well, that depends. That depends on what sort of glass is it, what have we done to it, and a number of other factors. So if we talk plain glass with no tinting, just a standard 6 mil pane of glass, about 90% of the energy will go right through the glass and land on the furniture or on the floor or on the people that live inside that room. About 9% of it will be reflected off the window, and about 1%, and only 1%, is going to end up absorbed into the glass. So on a hot summer's day, you can put your hand on the glass, and that's why the glass will feel cold. Only 1% of that energy is absorbed in the glass. So you touch a pane of glass on a hot day, it's still going to be cold. Now, if we put on a silvered mirrored film with about 20% light transmission, so only about 20% of the energy is coming through, because it's silvered or mirrored, 60% of that energy is going to be reflected back out. But remember, with the tint on the inside, it's going to go right through the glass twice. So some of that energy is going to be absorbed in, and in this case, around 20%. So on a hot summer's day, a mirrored tint on a window will feel warm to the touch. So this glass will now feel warm. Now, if we use a metallized neutral film, so we're talking still a 20% light transmission, but this time it's not mirrored, it's just a dark tint. About 20% of that's going to be reflected off the front, and 60% of it's going to be absorbed into the glass. So on a hot summer's day, in this case, the glass is going to feel hot to the touch. You'll put your hand up near it and you will feel a lot of heat in that glass. So what actually happens to that? Strangely enough, most of it doesn't end up staying in the glass. Some of it will be absorbed into the frame. Some of it will be radiated into the room, but most of it will be radiated back outside because of what we call convection currents. So the air movement, even on a still day, the still air movement, and the outside generally being cooler will tend to move the energy away from the glass. So you can see in this picture here, it'll be re-radiated outwards. So the highest percentage will be radiated out from the glass. Some of it will radiate in. Most of this is what they call a localized heating. And that's something that you've got to be fairly careful of. If you're talking to your customer about this, and they'll then, afterwards, they'll put their hand up next to the window and they'll go, oh, I can feel the sun coming through that. I can feel I can feel the heat. That's a localized thing around the glass. That's not what's transmitted into the room. This re-radiated inwards tends to just be in localized area around the glass. Some of it will end up in the room if it's transmitted through. So in this slide, we're talking total solar energy rejected, or TSER. That's the percentage of solar energy rejected by the glazing system. How much energy did we reflect away and not allow into the room? So TSER. Its opposite is solar heat gain coefficient, which we'll see in a couple of slides, that one. But one is basically the opposite of the other. So if you've got a TSER of 60, its solar heat gain coefficient will be 40. So one is the opposite of the other, well, percentage. Really what we're saying is this is the amount of energy rejected, the amount of energy that did not make it into the building. However, you can have two films with the same TSER, but look different. So different films will reject different parts of the solar spectrum. So for example, here we've got two films, Prestige 70 and Night Vision 35. Prestige 70 is a very light tint. The number here is the tint level. So this is the amount of sunlight that is rejected, that passes through the film. So this one, 35, a lot less light is passing through the film into the building. The bigger the number, the more light. The smaller the number, the less light. Prestige 70 and Night Vision 35 have got a TSR of 50 or 51. So their TSR is the same. They're both rejecting about the same amount of energy, but this one's almost not tinted and this one's quite dark tinted. They've both got the same energy rejection, but they look completely different. So you've got to be very careful when your customers have had people in from all sorts of installers and they've said, oh yeah, the TSER of this is better than that one. So, this one's a better film because the TSER is higher. Yeah, but it may not be what the customer wants. Try and figure out, like, are they more concerned about glare? If they are, then this would be a better one. They're more concerned about heat, then this would be a better one. So with a different TSER, you can get completely different look on the film. Sorry, with the same TSER, you can get completely different look on the film. That's what I was saying, is the solar heat gain coefficient is the opposite. It's the amount of energy that passed through. So the solar heat gain coefficient is the amount of energy that actually ended up in the room. So if people talk about solar heat gain coefficient, just subtract it from 1 to get the TSER. The next one, shading coefficient. This is an old school conversation that I try to avoid these days. TSER or the solar heat gain coefficient are a better way of describing it. Shading coefficient essentially is the same thing. The lower the number, the better it works. So the lower the shading coefficient, the better the film works to keep the room cool. This essentially is a very similar thing to to the other figures. So I don't tend to talk about it nearly as much, but you'll often find our opposition will talk shading coefficients, and we do still put shading coefficients in all of our data sheets, so they are still there. But it's better to use the solar heat gain coefficient or the TSER.
Michael, if
Yes.
I can stop you for a moment, please. I have two questions, and I think I'd rather ask them now than wait, if that's
Sure.
okay with you.
No, carry on.
The first question comes as, does the temperature of the room have any effect on the absorption of the heat? Say if the room was air conditioned on a really hot day. So does the temperature of the room have any effect? So that's the first question. I don't know if you want to answer that, and then we'll go into the second question.
Okay, the answer to that is yes, but not to any great extent. So lowering the temperature inside the room will have a small effect on this, but on the whole, no. It's based more on the energy coming in from the sun. So not enough that it will muck around with your calculations. And the second question?
Sorry, I apologize, I was on mute. Thank you for that. The second question is, can you put film on both sides of the glass at the same time to reduce more heat?
Yes, definitely. We will be talking about that one later. It's not unusual, for example, for someone to have a security film on here because they're trying to stop breaking an entry or something, but they're also concerned about the shading, so they'll put a tint film on the outside. That prevents you from having to put two films, a film on a film, tint the tint or tint the security film. Yes, that's quite commonly done. And in some cases, if you put the film on the outside, you will get better results than if you put it on the inside. So yes, it's a good idea to put it on the outside. You will lower the warranty because anything on the outside will degrade slightly more quickly than anything on the inside. But yeah, that's definitely a possible, quite commonly done.
So just to clarify, if you're putting a film on the outside, we do have the EX range, the exterior range,
Yes.
because the UV stabilizers are in a different position to the interior version. So just wanted to flag that as well.
Yeah, I've got a slide coming up on exterior films, but yeah, essentially, yes, you can definitely put them on the outside, but make sure you choose an exterior film because, as Kim was saying, they've got UV absorption in the top coat, which is the side you can touch. As well as in the adhesive, which normally if it's on the inside, the UV strikes the adhesive side first. So in a window film, the biggest UV absorption is in the adhesive. But in the exterior, we've put a good deal into the top coat as well.
Thank you for the questions. Please keep them coming in, and thank you, Michael, for answering that. Thank you.
No problem at all. Okay, emissivity. Emissivity is the ability of a film to absorb heat and reflect it. Unfortunately, 3M has deleted our thinsulate range, which were really good at this. We were having some issues with the durability of the films, so the US has now stopped production. So we no longer have thinsulate films. We are bringing in a bigger range of the LE series of films or low emissivity films. We're looking at bringing in a larger range, including an LE70, which will be a very light tint, but help to keep the room cool. Essentially, emissivity is the ability of a film to absorb heat and reflect it. So it will take the heat here and bounce it back into the room. Most people look at that and say, well, if you can have a film here on the window to prevent the heat coming in from outside, why doesn't it work in reverse? Why doesn't my heater or my wood fire, why does that heat escape through the window? And it's because of this. This is a really important graph to understand, and I'm going to explain it fairly carefully. This line here is the energy from sunlight. So we've got a little bit in the UV. This is what will burn you. This is what will give you sunburn. This is the visible part of the spectrum, and this is heat from the sun. Then about this point, the heat from the sun stops. And that's when the far infrared, this is energy from the heater. So any heat source that you've got within your house is far infrared. You will feel the heat from the heater. It's different to the near infrared from the sunlight. So they're different wavelengths or different parts of the spectrum. Window films are superbly good at blocking in this area, but they're notoriously bad at blocking far infrared. As I say, our LEs and when we did have it, the thinsulates would block the far infrared quite well. So to block the far infrared, you need quite different chemistry in the film to block this. So the films are very good. Just the layer of polyester that we use as the base will do a very good job of blocking near infrared and UV. So just the base film blocks the UV, and then the tints that we put into it block this part of the spectrum. So we can have different films doing different jobs. We've got our prestige films, which do a really good job. So a graph of a prestige film would look completely flat through the UV because we blocked all the UV, would jump up here nicely because it's giving you most of the visible light back, and then drop down to almost nothing through the near infrared. So with the prestige, we've chosen to allow visible light through, but block near infrared and UV. So what we can do with the window films is choose which parts of the spectrum that we block. That's why it's quite important to understand this. So you can't block this very easily. So it's very difficult to stop the window film allowing heat to go back out of the room. Okay, the next one is UK and R value. This is where it gets a bit complicated. So bear with me. The U value is an imperial measurement measured in British thermal units per hour square foot Fahrenheit. And I reckon everyone going, oh my God, what the hell does that mean? Essentially, it's a measure of how much heat passes from one side of the glass to the other. It's energy transmission. It's how much energy went through that glass. That's the old imperial units. That's the ones that the Americans tend to use. The K value is the same thing, but metric units, watts per square meter Kelvin. Kelvin is a temperature measurement. So, 0 Kelvin is minus 273 Celsius. So that is the same thing using metric units. Now, interestingly enough, everybody actually knows what the R value is, but you may not have realized it. The R value is how much energy didn't pass through the window or didn't pass through the surface. It's the reciprocal of U or the reciprocal of K. So R is 1 over U or 1 over K. We all know what this is. Everyone knows it and loves it. Everyone with pink bats in their roof with an R value of 4 or 5, that's what it is. That's your R value. It's how much energy did you actually manage to keep in the house. So we can swap K and U by doing this. If you've got the U value, multiply it by 5.678, you'll get the K value. So it's quite easy to swap between these units. In most measures, you'll never need these. If you've got a building engineer, he may want to talk about them and he may be interested in these, but these are all given to you. We unfortunately will give you the U value in BTUs per hour, but if they wanted the K value, multiply it by this. Confusingly, our industry often refers to K as U, but uses metric units. So you've got to be very, very cautious. What's the U value? And they want it in watts per square meter Kelvin. They're actually asking for the K value, but they've asked for the U. And these two measures are different by that amount. So, for example, where we talk about an R value of our pink bats of 5, in America, their R value could be 14 or 15 or 25 or something, because their R value is calculated on their imperial unit. I'm probably losing most of you, and most of you are totally confused. Really, from this, if you get any questions from any customer, and it will be a building engineer that asks this, your average house owner would not have any concept of what this is or what it does. If you get a building engineer asking this and you are concerned that you're not giving them the right answer or you don't know, feel free to ask. This is what, this is part of my job to understand this. I can demystify this for your customer. But just be very careful when they're asking for the units. So make sure if they say, what's the U value? Ask them, are you looking for the imperial U value or the metric U value? Because it's actually the K value. Just check on the units. Right, with that, I'm going to leave it at that because everyone's totally confused. And we're going to go on and look at, well, what films have we actually got and what do they do? So the films we've got and what they do really boil down to whether it's a premium film, an advanced film, or a basic film. For the premiums, we're talking prestige, and there's also a ceramic in here. We do sell the ceramic purely because our competitors sell one as well. But I think our prestige is better, so I'm just leaving this one as prestige. Then we've got night vision, neutral, and classic. So really, I'm going to talk about those 4 films. What are they and what do they do? So this is the top of the pile, does the most. Unfortunately, it will be at the highest price, down to the classic films, which will be at the lowest price. But these all have features that may be particular to your customer. So that's what I was saying right at the beginning. If they've got features that require prestige, your customer needs to be aware that that comes at a price. They may choose that what they want is probably not quite what they thought, and they might go down to one of these other films, but essentially that's the way it works. So kick right off with prestige. A multi-layer optical film, or MOF. Essentially, there are hundreds of layers of film that have been very, very precisely constructed. How they do this, I don't know. I've never seen the factory that makes this, and I wish I could because it would be pretty amazing to see. So in a thin film, we're talking microns, we've got hundreds and hundreds of layers. And what happens is as the light passes through those, we can actually selectively bounce the heat off. So prestige is particularly good at allowing the light through, but not allowing the heat through by having essentially a series of louvers or a series of layers that reflect the heat. It was inspired by nature. This butterfly here is called a blue morph. This butterfly has no pigment in its wings, yet it's shaded blue. And everyone goes, well, how the hell does that happen? Because of the shape of these, the scales within the wings, the light passes through those scales, and like a prism, it bends and bends off the blue light. So it allows the other frequencies of light through, but it reflects the blue part of the spectrum. And it does that by the distance between these layers in the scales, so in these scales. We've done the same thing, but by changing the distance between these, we've gone out of the blue part of the spectrum and we've decided to reflect the heat. So we can reflect the heat, and with the correct spacing, we can also reflect at the other end of the spectrum, the UV. So a very, very clever way of doing that. We're not absorbing heat, we're not absorbing any of the energy, we're simply reflecting it off. So prestige is particularly good at going on a window and not heating it up. Okay, the range, 70, 60, 50, 40, mainly in the lighter end. The visible light transmission of 70 means it's a very light tint. And this is the same picture that we had before, and you can see these ones are untinted and these ones are tinted. I believe they used a 70 or maybe a 60 on these, and it's very hard to tell that they were ever tinted. It won't change the external look of the building. We've already talked about that. Natural light transmission, so you don't need additional internal lighting because you'll be getting natural light into the building. Low internal and external reflectivity. I'll talk more about that in the next slide for night vision, but external reflectivity means that it will look like a mirror from the outside, or it'll give you privacy from the outside. Internal reflectivity is what that poor couple down in Christchurch was suffering from. Their mirrored tint had extremely high internal reflectivity at night, and that's quite common with some of those tinted films. So prestige has got a very low internal reflectivity. Essentially what we mean by that is that at night, you won't end up looking at yourself in the window, you'll still be able to look out of the window. So that low internal reflectivity means you can still see out the window at night. They're not metallized, so there won't be any signal interference and you can't get corrosion. Some metallized films will corrode over time, particularly in places like Rotorua or situations very close to the sea where you get a lot of sea air. You can get some corrosion occurring around the edges of the film if it's metallized. Prestige is non-metallized, so you can't get signal interference because there's nothing to block it and there's no metals to corrode. 97% infrared rejection. So basically, of all of that infrared energy coming in, we're actually reflecting 97% of that back out. And the warranty is 15 years, commercial warranty 15, and the what we call a limited lifetime residential warranty. So long as the person that bought the film and had it installed owns the building, we will offer a warranty on it. We had one where a couple came to us about 30, 40 years later saying, oh yeah, the film's not looking that great. Here's the warranty card and here's the receipt. So we paid for all the window film to be replaced. Yes, it does happen. Very rarely, but it does happen. Okay, the next one, night vision. Night vision's been around a lot longer than Prestige. Night vision is unusual. It's got a warm bronze color rather than a grayish blue, which is Prestige. Prestige is more of a gray blue color. Some people like that warm bronze color and they particularly choose it because they like the color. Not really, I'm not a big fan of the color, but some people like it. It is reflective from the outside for privacy. So a night vision window from the outside will be very difficult to see in. So we sell a lot of night vision into customers that are particularly looking for privacy from their neighbors. They want a tint on the window. They don't necessarily want a very dark tint. We've got a range from very dark to not so dark. But that's very, very, very commonly used for privacy. It does have a very low internal reflectivity, which is why it was called night vision. Nothing to do with people running around at night with green tinted goggles and that sort of thing. But it's purely that you'll be able to see out the window at night. So your vision out the window at night. We use carbon as a pigment. So there's no metals in there, but we're using carbon. That carbon means that it won't fade. We get a lot of people saying, oh yeah, can I have some of that film, that purple film for my windows? Well, no. What they're looking for there is a tinted film that will fade over time to purple. These won't do that because they're pigmented with carbon. We found that this is quite a selling point for residential customers, particularly for privacy, that still want to see out, and for commercial customers that want privacy without a mirror. 12-year commercial warranty this time rather than 15, but still the limited lifetime residential. Got a good story for night vision. Before the days of Prestige, we had a customer, an architect, phone up saying they were doing a job in Wanaka, and there was a lovely house up on the hill with a beautiful view out over the lake, architecturally designed place. In the end of the main floor was a double-story cathedral. So glass from floor to 2 stories high in a lovely peaked sort of cathedral end. And right in front of that window was a dining table that seated 22 people. So it was a big dining table with the most fabulous view out over the lake. The architect said, look, we've put this building in and we've made a horrendous mistake. The owners have come back saying that while they love it, they can't use the dining table during the day. They've measured the temperature on the dining table to be 45 degrees. It would melt just about anything they left sitting on it. That was because the sun streamed through the window and heated up the dining table. So they said, look, we need something that's going to reduce the heat on the dining table during the day, but the customer's biggest requirement was the ability to see out at night. They wanted to be able to see out of those windows because they have dinner parties, 22 people around this table, and they want to see the lake. So at these days, I would have recommended Prestige. It would have done the job beautifully. In those days, without Prestige, we recommended night vision, and they went on, I think it was a night vision 35, and we got a lovely letter back from the owner via the architect to say, thank you so much. It's perfect. It's lowered the temperature on the dining table to manageable levels during the day so they can use it, but they can still see out at night. So night vision was the way to go for them. It was just what they needed. The neutral range. The neutral range, I don't have a picture in here, but they're a neutral gray in appearance. These ones when I say neutral, they are fairly neutral. It's a neutral grey. It's it's got a good abrasion resistant coating for durability. It works really well. Great for residential and commercial. What we find is that we'll sell a lot of neutral films into residential customers that either cannot or do not want to pay the higher price for the night vision or the prestige films. So they're mainly looking for glare reduction, or they're mainly looking for some heat reduction. They're not too concerned about the tint level. So we do sell a lot of neutral for that sort of situation where price is obviously a big issue for them. So very commonly used. A lot of it goes into retail as well, retail public spaces. Which brings me on to the classic range. The classic range, these are the lowest cost of the films. We tend to use these more for commercial applications where every dollar on a square meter is going to be important because they're talking about hundreds or even sometimes thousands of square meters. Look at the UN building there. The classic range will end up with a silver or mirrored look. They are reflective, but they do tend to be cost effective. So because they're the cheapest ones, they tend to have a fairly quick payback on energy saving, particularly in those commercial things. They do have very good heat and glare reduction. We don't tend to sell as many of these into residential because they're actually metallic, and they will cut down on some cell phone reception and things. Usually in buildings, there's enough space for to actually get enough reception through. So what we've got in this range is Affinity 15 and 30. So Affinity 15 is quite a dark tint. Affinity 30 is lighter. So it's about a 90% glare reduction. We're saying about an 8-year warranty. Don't guarantee. I've actually got a better slide on warranties coming up. But so these ones, while they're not specifically mirrored, they do tend to be very reflective. Silver P18, this is the granddaddy. This one has been around 55 years. It was painted in 1966. So that's how long that film's been around. That's the first of the window films. It does an amazingly good job. This is the go-to product if you need a highly reflective mirrored look. This is the one we tend to recommend for those interrogation rooms or interview rooms where people don't where you don't want to be able to see into the viewing room, but you do want to see into the interview room. So this is a very common film used. It's the granddaddy, and we've sold truckloads of this over the years, and it's very, very good at what it does. Quite commonly used in commercial buildings anyway, where they don't care what it looks like from the outside, but they're just more concerned about the amount of heat and light coming into the room or into the office. This is commonly used because it is quite a dark tint. You've often seen, you've been into offices where there's too much light and people have got pieces of paper stuck to the window or cardboard around their monitors just so that they can see them. So this will often reduce that glare. Silver 35 is a silver version of P18. So these are not silver, but they're reflective. These two are silvered. Cost effective. External films. This goes back to to what Kim was talking about before. Where might you use an external film? So I would use an external film where you can't get access internally, and I would be looking at things like skylights or atriums where you don't want to have to build God knows how many floors of scaffolding to put the film on the underside of skylights in an atrium. I would also look at external films of areas of high thermal stress. So if you've got a window that is particularly prone to being thermally stressed and you're really concerned that if you put a film on the inside, you'll end up breaking the glass, an external film will probably work because the energy doesn't go through the glass to get to the film. The film is on the outside and will reflect it. So in this case, you can use it in areas where you think an internal film would fail. And as I was saying, it's also commonly done if you've got a safety film already on the inside, then you can put an external film on the outside. What I was saying before is the external films, you've got to go with caution with the external films. The reason I say that is that the external films, you can't use an internal film in an external application. It won't work. The external film has got a lot more UV stabilization in the hard coat on the top, because when it's on the outside, that's what the sun's going to strike first. An internal film has got most of its UV stabilization in the adhesive, because when it's on the inside of the glass, the sun passes through the glass, then it hits the adhesive first. So that's why we put the UV stabilizer in the adhesive on the internal films. Now, this is the point I want to make. Another interesting point. We get a lot of customers, particularly residential customers, where they've got a large bank of windows and in the middle is a set of French doors. So you've put window film on all of these windows and they're very happy, but the doors end up folding outwards and they spend all summer with the doors open. So with the doors folded outwards, the interior film is now an exterior film and is getting an absolute hammering from the sunlight. So it's not unusual to see the doors amongst a whole lot of other windows fail first, and in some cases fail after 6, 7, 8 years, as opposed to 12, 15 or limited lifetime. So you will see a failure on those windows because they've spent all summer open. So what do? The solution to that is use an external film on all of the interior windows. You can use external film on the inside, no problem at all. The external film still has a full UV stabilizer package in the adhesive. We've just added extra stabilizer into the hard coat. So the external films are actually an internal film with extra stabilization in the hard coat. So what you do is you choose an external film to put on all of the windows. That way they'll all match. We've had some people say, I'll use an internal one on these ones that don't open, and then I'll use the external version of the same film just on the 2 French doors. Yes, it works, but because they're out of different batches and they are actually different films, you can end up with subtle differences when the 2 windows are side by side, and you'll look at it and go, oh, that doesn't look too good. So you can see the difference between the 2 because they're actually different films. So what I would recommend for those French doors, when you've got a lot of other windows around, just use an external film on all of them, and that would work quite well. Not so much an external film, but just because I've remembered to say it, when it comes to warranties, we will and do pay out on warranty. Sorry, I should change slides. Warranty and care. This slide basically will cover all of the warranty situations. What I'm going to do is I'll cover this first, then I'll tell the story in the next slide. So essentially what we're saying here in New Zealand, here's the warranty period. Insulet we're no longer doing, so we can ignore that one. Prestige and the ceramic version are both 15-year in commercial applications, or lifetime. We actually officially refer to it as limited lifetime because it's limited to the original owner. Residential. All of these are residential limited lifetime. The night vision is 12 years. The neutrals are 10. The neutral and classic are 10. Now these ones, exteriors. Exterior vertical, so you're talking completely vertical. Residential and commercial are 7 years. So we'll warrant those on the outside for 7 years. However, if it's sloping or it's horizontal, so we're talking overhead stuff, awnings or atriums or that sort of thing, anything that's off the vertical is now 5 years outside. The exterior silver, which is the basically like the one of the classic series, 4 and 2, because we know these are not going to last that long. And then there are safety and security ones as well. They're in there too. What we do need to say here is that the warranties are officially based on 3M licensed installers. If you are going to do a lot of these, come and talk to us and we'll look at making you a licensed installer. And basically by doing this course, you are doing part of what we need for a licensed installer. The reason we will change the warranty for a licensed installer is we want to make sure that you know what you're doing when it comes to installing these films. So part of the licensed installer is being able to correctly install the films as well. And that's something I can't do virtually. That is a hands-on job. So that's the warranty information. So it brings me on to care and maintenance. So
Sorry, Michael, before
Yep.
you jump into care and maintenance, you have a question relating to the exterior films.
Sure.
Do they require edge sealing? I know there was reference there to pooling of water, but how do we feel about edge sealing?
No, don't edge seal the exterior films. They don't need it. And I know a lot of the opposition must be edge sealed. That's an advantage of our films. We do not recommend edge sealing them unless you know the water will pool up. So if you're on a sloping piece of sloping glass and there's the frame, you know you're going to get water pooling between the bottom of the glass and the frame, then you would want to edge seal that bit, which will be sitting underwater when the water pools up. But for a vertical exterior, no, we don't recommend edge sealing them. Down that road lies madness. You can edge seal them, but it's not going to make any difference. Our film won't last any longer if it's edge sealed or it isn't. We've done a good enough job protecting it that don't bother. And it's a big advantage for us. And we're delighted that we don't have to.
Thank you.
Okay, care and maintenance. This is actually, we're doing pretty well for time. This is the last slide I've got before we break, because after this we'll get on to the safety and security stuff at 1 o'clock. But I've got a couple of things I want to say here first. Care and maintenance. When you install it, what we say is get your customers not to wash the windows for about 30 days. If they do wash them, common window cleaning solutions, they can use Mr. Muscle, they can use any of the glass cleaners that contain ammonia, doesn't bother us. But what you'll find is if you pay someone to come and clean your windows, they're going to be using detergent. They'll probably be using Sunlight or just a simple dish soap, that sort of stuff. Why? You don't actually need to use anything as expensive as an ammonia-based cleaner. They say, oh yeah, we put ammonia in there because it helps for a streak-free appearance. If you know what you're doing and you do it correctly, you're going to clean the windows and you won't end up with streaks in it. Part of the installation course, we talk about cleaning of windows, and I'll show you ways to clean the windows with detergent and water and get it streak-free. So common window cleaning solutions are fine, but you can just say to your customers, you can use ammonia-based cleaners, but don't bother. Synthetic sponges or soft cloths, don't use bristle brushes on them, but that's purely because you're going to scratch you can damage and scratch the edges. Soft squeegees, rubber squeegees, sponges and cloths, they're all great for cleaning. Brings me on to a lovely story. One of my favorite stories where we got hung out to dry, but I'll take the cost of that for the story. I had a phone call from a house owner in Freeman's Bay, which for those of you who are not Aucklanders, it's quite an expensive suburb. And they had quite a large house with a lovely view out over, over the harbour bridge, and a really nice looking house. And she said, I've got a real problem. We've got window film on our windows, and they've got a big long section of windows. And she said, one of them's deteriorated. Okay. Yeah, it was covered under the warranties. Like, she had all the documentation. So I was quite curious. So I went out and had a look, and she said, look, it's really unusual. It's pitted. It's almost as though it's got little holes in it. Oh, well, that's strange. So I chose to go and have a look. Like, normally I just send an installer around just to go and sort it out. But in this case, I thought there's something going on here. It piqued my interest because I knew there was something not right, but I couldn't put my finger on what it was. So I went and had a look, and I looked at this thing, and there was a spot probably about that big, sort of, if you can't see me, a spot probably 100 millimeters around. And it looked really pitted. It looked as though there were little holes in the film. And I thought, that's odd. It was only on one window. So I said, yep, it's okay. I'll organize an installer to come and have a look at it. So got the installer to go and do the job to replace the film, all under warranty. I was paying all the costs of it. And the owner wasn't there, but the housekeeper was there. Just shows you what sort of house it was if there's a housekeeper. And the housekeeper said to the installer, you know, you've been fooled. And the installer said, well, what do you mean? And the housekeeper said, the owner's 3-year-old got hold of a can of Mr. Muscle oven cleaner and was trying to help by cleaning the windows. So he sprayed oven cleaner onto the glass, well, onto the window film. Oven cleaner is incredibly caustic. So I'm surprised there wasn't as much damage as there could have been. So the caustic had bitten into and eaten holes in the window film, causing the damage that we'd seen. What really got me was the owner knew. She knew her son had done this, but still she thought she could claim a warranty on it. And she did. So the installer phoned me and said, what do I do? When I said, well, it's, you know, by this stage, you might as well have just replace it. So we never went back and hit her up on it, but I have learned from that. Now I know what oven cleaner looks like on window film, and I won't be fooled again. So don't use oven cleaner. It's not a good cleaner for window film, but the common cleaning window cleaning solutions will be fine. Ammonia won't affect the the cleaning solution. Won't affect the window film.
Michael,
Yep.
just to jump in here, because we're talking about care and maintenance, but we have a very good question around install, and I'd imagine it would vary by season, but the question is, when applying the tint, does the amount of soap and IPA in the water differ depending on the type of tint? So not only the tint make, but I would imagine seasonality as well. So I just wanted to raise that as part of the whole install process.
Good question. I was actually going to talk about drying and things. Like, I don't have a slide on it, but in care and maintenance, I was going to talk about drying anyway. But okay, firstly, I can't tell you how much detergent goes into the water. We recommend using just Johnson's baby shampoo, nothing else. I know some people use other things like Slip G, or there are a number of other products out there. That's fine. I don't have a problem with it, but we recommend Johnson's baby shampoo because it's a neutral, non-colored, very mild detergent. How much do you put in there? The question really is, it depends on the time of the day and the month of the year. So on a hot summer's day, you're going to need more detergent to give you more slip on the window. In the winter, you're going to need less detergent. And I've actually even come across some situations where the installer said, at particular times of the year, we don't use any detergent at all. We can actually get the window film on just with the water alone. That's a bit of a risk, but they reckon they could do it. So the amount of detergent that goes into the water will depend on the temperature. The hotter it is, the more you'll need. How much? I can't tell you. It depends on your particular situation, the size of your containers, but just a few drops per litre, maybe 5 ml per litre would be more than enough for most situations, but it may be as low as 1 or 2 mils in the winter. Now, the next question,
would it vary by a type of tint versus a
No.
prestige versus an affinity?
No, it does not vary by tint type. It varies by how much slip you need on the window. Obviously, you may end up with a little bit less detergent in a safety or security film, which is much heavier, because otherwise it'll just drag itself off the window, and you need just a little bit more grip on that. But usually no. But the one thing I've got to say here, and I heard Kim say the words IPA, please hear this. Do not ever, under any circumstances, put IPA in your slip solution. You will end up with massive, massive problems. The reason for that is that people think, oh, I'll put IPA in there because it'll help to dry the window more quickly. It'll help to drive the water off more quickly. No, what it does is it creates bubbles under the window film. And that is a big, big no-no. So please hear me. Do not put IPA in your slip solution. It will cause you problems. So never, never, never put IPA in there. There's only one installation in the whole of the portfolio that I cover where you use IPA, and that's paint protection film on cars. It's not window films. So never use IPA in your window film solution. What actually happens there is the IPA tries to dry very quickly, and it will take the water with it. If you've put that on your window and you've squeegeed it out and you think, yep, that's great. No, the problem is the IPA is still under there, and it's trying to drive off very, very quickly, and it will drive off more quickly than it's able to get through the window film, so it will end up causing bubbles. Which brings me on to another point that we need to talk about with care and maintenance. It is possible, if you don't squeegee hard enough, to get essentially to get bubbles forming overnight. They call them water agglomeration. So you end up with a bubble, sometimes sort of 50 millimeters across, where you possibly didn't squeegee just one part of the window quite firmly enough. That's quite common. Usually what we say is that tell the customer, if it's still there in a few weeks' time, give us a call, and they never phone back because they just dry out over time. If you had IPA in there, they wouldn't be water bubbles, they would be air bubbles, and they wouldn't come out. When they eventually did dry flat, you'll end up with a big circle, and that circle does not go away. So that's why I was saying is do not use IPA, it will cause you problems. So when it comes to drying, that's the way they say leave it for 30 days, because what you're simply doing is you're giving it time for the water to evaporate out from underneath. Because you put these on wet, and they are a wet installation, you've had to squeegee out as much of the water as you can. So squeegeeing the death out of them to get as much water out as you can will give you a much better installation going forward. But those are mainly questions for for an installer course rather than a sales and specifier course. But I know a number of you listening in will also be the installers as well.